All right, thank you to Krista. Thank you to my fellow panelists. I will take the panelist hat off and put the chair hat back on here. What a great discussion. Now I'd like to invite up to the podium, and really excited to be inviting him up to talk with us, Associate Administrator Robert, also known as Bob Cabana. Thank you, sir. I got to do an introduction for you, so if you don't bear with me. Last time he judged me. So Associate Administrator Cabana is a retired NASA astronaut, currently serving as NASA's third highest ranking executive, highest ranking civil servant. He's a senior advisor to NASA Administrator Bill Nelson and Deputy Administrator Pam Melroy. In this role, Cabana leads the agency's 10 center directors, as well as the mission directorate's associate administrators at headquarters. And thank you, sir, for making the time to be here with us today. Very much looking forward to it. Thank you.
Let's see. Let's get the charts up. Who's driving for me? All right, next chart. That was easy. So we got to start at the beginning, right? And NASA's mission. This is the coolest dang mission statement ever. NASA explores the unknown in air and space, innovates for the benefit of humanity, and inspires the world through discovery. How can you not get excited about that? This is an absolutely amazing time for our nation's space program, for our world space program. Look at all the things that are going on. And I was glad to hear that discussion at the end of the last talk on Artemis, because that's what I want to cover today. But I can't imagine a more exciting time for our nation's space industry than right now. Next slide. So I got to put this up here. I'm going to talk Artemis, but this morning, this is the one-year anniversary of the James Webb Space Telescope releasing its first images. And this image got released at 6 o'clock this morning. And I don't normally read my notes. I hate notes. I figure if you don't know what you're talking about, you ought to just not get up to the podium, and you ought to be able to talk without notes, right? But I got to read this to you because they wrote this so cool that I wouldn't do it justice if I didn't read it, explaining this. So this is the first anniversary image that got released this morning, and this is the Rho, I challenge you all to pronounce this correctly, Ophiuchi, Rho Ophiuchi cloud complex. It's about 390 light years from Earth, and it's the closest birthing area of stars to Earth than any other. So there's about 50 young stars in this picture. So now I'm going to read you this because it sounds so cool. All right. Huge red bipolar jets of molecular hydrogen dominate the image, appearing horizontally across the upper third and vertically on the right. These occur when a star first bursts through its natal envelope of cosmic dust, shooting out a pair of opposing jets into space like a newborn, first stretching their arms out into the world. In contrast, the star S1 has carved out a glowing cave of dust in the lower half of the image. It is the only star in the image that is significantly more massive than our sun. The light-colored gas surrounding S1 consists of, polycyclic aromatic hydrocarbons. And I talked to our planetary and stellar scientists, and I said, so aromatic carbons, what do they smell like? And they said, no, Bob, that's not what that's about. A family of carbon-based molecules that are among the most common compounds found in space. So, a lot of fancy words there to say that Webb is absolutely amazing. I remember when it launched on Christmas Day, I remember getting over to the laboratory and seeing the first APL and seeing the first images that were released from the Institute, and I just couldn't believe it. Hubble has always been one of my favorites, especially the deep field. Everybody knows the Big Dipper. You can go out at night and look under the handle of the Big Dipper where there's nothing and hold your hand up like that and look at your little fingernail. And what Hubble found there were not just hundreds of stars, but hundreds of galaxies. And Webb has found even more, look back even further in time. It's changing our understanding of our universe. It is absolutely amazing. So that's 1-year anniversary photo for you to enjoy. Next slide. So Artemis, right? We're going back to the moon. And what an aptly named program. Of course, we went with Apollo back in the 60s and 70s. And Artemis in Greek mythology is the twin sister of Apollo. very aptly named for the program that's going to put the first woman and first person of color on the moon. But I want you to leave here understanding, why do we explore, all right? And there's 3 reasons: science, national posture, and inspiration. Going back to the moon, on the surface of the moon, we're going to learn so much more about the fundamental planetary science questions that helped form our planet. We can do that on the moon. It's been undisturbed. From a national posture point of view, you know, NASA enhances U.S. competitiveness. People look to us. Our international partners look to us for leadership. It is so important. It increases our national posture. And inspiration, it goes without saying. You know, I mean, I'm a child of the Apollo generation, right? That's what inspired me to do what I've done, where I've gone. And Artemis is inspiring the next generation of explorers. It's our future. This is where we're going. Next slide. So that's last November. That is the launch of Artemis 1. And I got to tell you, it was so danged amazing. I was in the Launch Control Center, and the administrator and deputy administrator were there. And when we came out of the T-minus 10-minute hold, I grabbed them, and I took them up on the roof of the Launch Control Center. And I almost put this picture in there, but I didn't. I always tell folks, do not take pictures like this, right, when you go to a launch, because a launch, pictures don't do it justice. When you see a rocket launch, I don't care what rocket it is, I don't care what's on it. It is an emotional experience. When something leaves planet Earth on a rocket ship, it's amazing. It's sight, sound, feel, emotion, and a picture doesn't capture it. It's like you go to the Grand Canyon and you see it, it's absolutely amazing. You take a picture and you say, it's not like that, it's so much better. And that's what you need to do when you experience a rocket launch. But I did kind of step away, and I have a picture after I'd experienced it emotionally. I looked around and I saw the administrator and deputy administrator, I saw some other folks, and I stepped back behind the administrator and deputy administrator, and I have them silhouetted by the light of the rocket, looking up at it, and it captured the moment for me. And what's really cool, I took another picture after that, and you've got the Artemis, or the Space Launch System with the Orion spacecraft on it, right? And it's going up. And the way the contrail is and where the rocket is, it's heading right toward the constellation Orion, and you can see it bending over, and it's pointing right at the moon. And how cool was that, right? Well, that mission was absolutely phenomenal. It was a huge success checking out Orion and the rocket. The rocket performed flawlessly. Let's go to the next slide. You know, I love this shot. Orion looking at its furthest point, about 30,000 miles beyond the moon, looking back at the moon with the Earth behind it. That's where we're going. It went further from Earth than any other human-rated spacecraft. Okay, checking it out, checking all the systems out before we put a crew on it on Artemis 2. And it came home and experienced temperatures on reentry half the temperature of the sun. And I don't know if any of you were watching that when it was coming home, but I'm watching it live on TV, and it's like, it's amazing. You know, you've got this camera picture view where you can see Orion, and the Earth just keeps getting bigger and bigger and bigger. I mean, this thing is really hauling coming back. It was so dang cool. Well, I can talk about it, but I want to share a short video with you. It's only a minute long, and it kind of captures that whole mission. Can we hit the next slide, and let's see if this will play. Okay. Uh-oh. We can do this. We have the technology. And sound?
The Space Launch System is now counting down to liftoff of Orion and its maiden voyage to the moon. And here we go. Hydrogen burn-off igniters initiated. 7, 6, 5. First stage engine start. 3, 2, 1. Boosters ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
We are all part of something incredibly special, the first launch of Artemis.
1972 during
Little buffering, we'll get there. But what a great shot. Well, I would have loved to have seen that shot of the blue marble. Didn't quite get that far. All right, we'll go on to the next slide. Bottom line is, it was really cool. You got to see it splash down. We recovered it off the coast of San Diego, and we learned an awful lot from that first test flight. We still have some work to do before we fly crew on Artemis II, but we are progressing ahead. Next slide. Okay, so we got, I throw this up here. I put this in to keep Brad happy. You know, we're at the moon right now. This is Capstone. It was launched back in June of 2022, and it just completed its 6-month mission in this unique orbit that we're going to put Gateway in around the moon. And Capstone's helping us better define the characteristics of that orbit, and it was a huge success. It had some challenges. The team worked through the challenges, and totally successful launch of the Capstone. So thank you to Advanced Space for that. And you know, we look for bigger and better things, but even though it's completed its 6 months mission, it's still gathering data and working well for us. Next slide. So we're going back to the moon this year. The CLIPS program that runs out of the Science Mission Directorate at NASA, we've got a couple missions coming up. They've been a little bit delayed. One company, Astrobotics up in Pittsburgh, is waiting for the new Vulcan rocket, the ULA Vulcan, to be ready to launch it to the moon with a commercial lander. And Intuitive Machines down in Houston will also be launching to the moon, hopefully later this year, on a Falcon 9, delivering another commercial lander to the moon. What's unique about this program, CLIPS, is that we're in partnership with industry. NASA did not totally pay for everything for the mission. NASA has science on the mission, but these companies also went out and got other entities to pay them to go to the moon in order to break even and make money. And it's trying to stimulate this commercial economy, this partnership that we've been so successful working commercial partnerships here on Earth as we transition them to actually going to the moon. So we're going to the moon again this year with a couple of missions. Next slide. Artemis II. We're going to the moon with a crew next year for the first time in over 50 years. We're going to have a crew orbiting the moon, and what's unique about this crew, you will notice it has a woman, a person of color, and a Canadian on it. We're taking our international partners with us. And Reed Wiseman, the commander, this will be his second flight, naval aviator, test pilot, former chief of the astronaut office. Victor Glover, another naval aviator, test pilot, also his second flight. Christina Cook, absolutely amazing. She holds the record for the longest spacewalk by a woman. She also participated in the first ever all-woman EVA on the space station, her second flight. And Jeremy Hansen from Canada, F-18 pilot, really a sharp guy. This will be his first flight. And I think, you know, this is what NASA does. Space brings us all together. It binds us together, and we're working together. We're going back, not just on our own, but in partnership with our international partners as well as our commercial partners. Next slide. So, Artemis 3. Once we do Artemis 2 is going to check out the Orion spacecraft around the moon. It's going to check it out in Earth orbit first. It's going to go into this really highly elliptic orbit, make sure everything's right before we do the TLI burn to go to the moon, and then it'll do a free trajectory around the moon and back. And that'll be the first flight of Orion with a crew on the Space Launch System. Then Artemis 3, hopefully, maybe a year and a half, 2 years after that, is going to put us on the moon, all right? To do that, we're looking to use the SpaceX lander, and the suit that we're going to use is being designed and built by Axiom Space in Houston, and that is going to be absolutely awesome. Now, in addition to SpaceX building a lander. We've also gone out with a competition for a second lander to have that redundancy, to help keep costs down and have competition. And that was awarded to Blue Origin and the national team. And they are going to be utilizing that lander to land on the moon on Artemis 5. So again, the commercial partnerships, what we've learned working in low Earth orbit with industry is helping us as we move on and go to the moon and explore beyond as we work together. So that is going to be absolutely awesome when we make that happen. And we're going to the south pole of the moon. And the reason we're going there is because of the water ice. Eventually, when we get to the moon, you know, the important thing about this isn't like one and done, like Apollo. We were talking in the previous panel about the importance of sustainability and having the funding and a plan going forward. And I give our Deputy Administrator, Pam Melroy, so much credit. In my backup slides, I'll throw it up there if it comes out in the questions. But the architecture that we have put together, you know, it lays it out. It's objective-based. It's what do we need in order to learn on the moon that we can go on to Mars. That's the ultimate goal, is getting on to Mars. And it's laid out this structure, and there are different pieces. Some of it's for industry, some of it for international partners, but everybody has a role to play in helping us make it. And from a funding point of view, you know, if you don't get it all at once, you've got the pieces that you need to continue on. You just maybe have to move things out a little bit. But that was Pam driving that. She's involved our international partners in it. She's involved industry in it. Our government partners, we've all had a role to play in helping define these requirements and come up with this architecture. And I believe that's what's going to make this sustainable as we go beyond administrations, because I totally agree. We cannot continue to change our focus. We need a clear focus of where we're going and how we're going to get there and then execute it. Next slide. I talked about international partnerships. I want to bring up the Artemis Accords. We just had our 26 countries sign it, 27, including the United States. And the Artemis Accords are a set of principles. They're based on the Outer Space Treaty to create a safe and transparent environment to explore as we go beyond our home planet. Again, NASA brings countries together. We build relationships. We set the course and build the coalitions that are needed in order to be successful with both industry and our international partners. Next slide. This is Gateway, and Gateway is going to be this outpost around the moon in this highly elliptic orbit that will allow access anywhere to the lunar surface. It can serve as a safe haven. It can serve, develop systems that we need for transhabs as we go on to Mars. It will be a logistics outpost. It will be a place where we dock with Orion to transfer to the lander as we go back and forth to the lunar surface. Telerobotics can be done on the lunar surface from the Gateway. It is really important. We're going to be launching the power propulsion element along with HALO, the Habitability and Logistics Outpost built by Northrop Grumman, that will be taking the first element, HALO, to the Gateway orbit. And then on Artemis 4, we'll be taking the International HAB and attaching it to the Gateway. So another critical element as we set everything up, exploring. And then finally, next slide. That's the ultimate goal. We're going to the red planet. We're going exploring. We're going in a sustainable way. And when we finally learn what we need to learn, establishing the systems and procedures and learning to operate away from planet Earth on extended periods of time, and we have what we need to go on to Mars, we are going to continue to learn and explore and go beyond our home planet, establishing a presence in our solar system beyond Earth. And that first step is Mars. What I'd like to do, I ran a little bit over, but I wanted to have 15 minutes for questions. We got at least 10 before you break for lunch. I'd like to open it up to any questions that you have about what NASA's doing and where we're going. Yes, sir. And please speak up.
Sure. My name is Frank Spellman. I'm the analyst with Price Tag. Thank you for your leadership and the agency has supported the Space Competition Director at headquarters. You refer to yourself as a member of the Apollo generation. A lot of us here are or will be as the Artemis generation. And we're stewards of that, especially in the space industry. What would your advice be to us as stewards?
Well, my advice to all of you as young professionals is, I'll give you I can't give you my leadership talk. That's at least an hour. But what I will tell you is, you know, stay motivated. Stay enthusiastic about what you're doing. And, you know, I'm really old, but I'm not dead yet. I got a few good years left. But I'm passionate about what we do. I am enthusiastic about it. This is important to our nation. Make sure that what you're doing, you're in a position where you really enjoy it, that you're enthusiastic about it, that you're passionate about it, and continue to learn and grow. Never stop learning, never stop growing. And when you're asked to take an assignment by your supervisor, never say no. There were a number of positions that I got asked to go do that I thought, I don't want to do that. And but I always said, aye, sir, ma'am, and went off and did my very best at it. Oftentimes you're going to get asked to do things that you don't think, that you might think you're more qualified than that. It doesn't matter. Or you might get asked to do something that you think, well, I'm not really ready for that. You wouldn't have been asked if you weren't, right? So charge off into it with passion and do your very, very best at it. And talent gets rewarded. If you work hard and do a good job, more is going to be asked of you. So never say no. Always do your very best at whatever you're asked to do, but maintain that passion, maintain that enthusiasm, continue to learn, be engaged, be in the moment. Don't worry about the past. Don't think too much about the future. Have a goal. You got to have a goal. And when you're leading a team, you got to impact your vision. You know, they got to own that vision. You got to clearly communicate a vision of where you want them to go, but make sure that you continue to grow, continue to learn, be passionate. And don't ever say no. Do your very best at whatever you do, and amazing things will happen, guaranteed. Yes, sir.
Yeah, I was following with at NASA's Mars Exploration Program, and I wanted to ask, you mentioned sustainability. What's NASA's vision after the first few Artemis missions, and how do you eventually get to Mars?
After
The first few Artemis missions.
So we are looking at what it takes to go to Mars, and that takes an awful lot right now, especially extremely reliable environmental control systems and a HAB module that can protect for radiation and a whole bunch of other stuff. So, you know, the goal is to learn what we need to learn on the lunar surface as far as developing the systems and the architecture. And much of what we do on the lunar surface is going to be translatable to what we do on Mars. Steph, have I got that one chart that shows, in my backup, can you go, keep going a little bit, keep going, one more. Yeah, if you look at, you know, what we're doing on the moon, it definitely maps across into what we need to develop to be on Mars. And we still have a lot to learn. We haven't, you know, operated away from Earth for extended periods of time for a long time. We've learned so much on the International Space Station, more than being an outstanding science platform. It is a superb engineering test bed for developing the systems that we need for long-duration spaceflight. But being able to do that in and around the lunar surface also is going to be huge in cislunar space to, again, develop procedures and systems that we need. So it's not like if we get these three things done. Back up 2 slides. I don't know if you can all zoom in on that. I don't know if you've looked at our architecture and what's laid out. You know, this is going to be an iterative process. Every year we're going to meet. That QR code, I promise you won't get a virus from it. I've checked it out myself. All right? And that'll give you a link to have we got the right one? Yeah. Okay, thank you. That'll give you a link to the architecture, and you can read for yourself what is required from an objectives-based viewpoint of what we need to learn and go on to Mars. Now, we have not firmly laid out all the requirements yet to go to Mars, what we need, okay? We're still working on that. And every year, the team is going to get together and better define where we are as we meet certain objectives to validate that we have the right ones to move forward. What have we learned? What do we still need to learn in order to execute? So this is going to be an iterative process. But the key is we've laid it out such that it will be sustainable. Yes?
My name is DeVar Seeks, and I'm with the Z Factor Fellowship. You mentioned that space is a way to bring the nations together, and it was really cool and exciting to see the Artemis Accords, and all the countries that we are bringing together. Obviously, there are some global competitors that may be looking for a different perspective in that. Do you have any insight on this so-called space race and just your perspective on where that's to go in the future?
So I want to see us remain a world leader. And if we are going to remain a world leader in many ways, we have to remain a technological leader. We have to continue to lead in space. And I think it's very important that we do not fall behind anyone else, all right? We are right now doing things that other people have not done and cannot do, but there are many that are catching up to us quickly. And I want to continue to see us lead. And that means we have to continue to develop the technologies and to operate beyond our home planet, paving the way to go onto Mars. The Mars Sample Return Mission, all the great science that we do. And, you know, it's not doing one thing in the exclusion of something else. And NASA has a broad portfolio across human spaceflight and science, and it's all interrelated. Technology development, everything that we do, and it is so important. The Science Mission Directorate is very much a part of what we're doing as we go back to the moon with Artemis, and our exploration systems, our space operations, our science, our technology mission directorates, we are all linked together with common goals. It's not like it's an independent thing. But yeah, there are folks, you read the news every day, right, that are doing amazing things. It's a lot easier to do it when somebody else has already done it, and you can learn from them rather than doing it first yourself. I like being first, and I like continuing to lead, and I think that's what we need to do.
My question is, in terms of branding, what do you believe NASA's role is in showcasing and marketing commercial space exploration to a public that may otherwise still be skeptical?
So we are an enabler, all right? That's how I see our goal as far as commercial space is concerned. You know, when we transformed the Kennedy Space Center to a multi-user spaceport, I can't make companies successful, but I can help enable them be successful. And there were a number of companies that were not successful during that transition that were utilizing NASA facilities that we no longer needed, and they went by the wayside. So I see it as our role to help enable commercial space, all right? We would very much like to transition beyond the International Space Station and create a commercial environment in low Earth orbit, hence commercial LEO destinations. And as we go on beyond the moon to Mars, we would like to leave behind a commercial capability on the lunar surface. So I'm kind of a history buff, and I believe history is really important. You go back to early aviation. You know, people ask me, well, what do you think about all these folks flying in space or then suborbital flights and like that? I think it's absolutely great. I heard that we're not getting the numbers that we thought we were going to get, but all things come with time. You know, it's not, this is going to grow. If you look at early aviation, you know, it's pretty amazing when you go from December 17th, 1903 to 1969 and walking on the moon in 66 years, right? If you look at the early aviators after World War I, you know, you could go to the county fair and pay $5 or whatever to go up in a Jenny and see the farm from 2,000 feet. That's kind of like these suborbital flights now. If you look at folks that were flying commercially, you know, on the Pan Am Clipper and so on, those were the very elite that afforded that. You know, folks like me were riding steerage in a steamer across the Atlantic. So, you know, in time, things are going to pick up. Space, or aviation rather, from December 17th, 1903 to today, it's been exponential, right? The growth in knowledge and how aviation is and how we fly. People think nothing of getting on an airplane and jetting anywhere. Space is still back on that flat part of the curve when it comes to how we're operating in space and what we need to do. It is still a very harsh environment. It's still very costly. But as we continue to grow and learn and enable commercial operations and find ways to do things more cost-effective and efficiently, it will become something that hopefully will become open to more. So we still got a lot of work to do. You had a question over here. Hmm?
How do you see NASA's plans with international partners and commercial partners, and how do you maintain the interoperability of the systems as we look at the Mars?
Ooh, that is a great question. We have requirements. We have laid out requirements for the various interfaces and systems. So to ensure that there is that interoperability. And we have provided these to everyone, not just our partners, but to everyone. You know, anybody can have access to the requirements for what size should a docking hatch be? What is the size of the international docking adapter, you know, that we utilize, so that we could have that interoperability between others. So the requirements are laid out there, and it's all open on what is needed and how we operate so that we can have that operability. I won't say it's without challenges, you know, especially working with, you know, when you're building hardware in one country and integrating it for the first time on orbit. But we have done this. Look at the International Space Station. What a phenomenal vehicle that is on orbit. It has set the standard for how we operate together in space with our international partners. When I look back on the assembly sequence and how we did that, building hardware all around the world, the testing that went into it, using emulators, using you know, hardware that was taken back and forth across the ocean, so that when we did get on orbit, everything worked. You know, I'll never forget that first space station assembly flight that I had the privilege to command. You know, we spent hours testing software, and the space station was originally ship and shoot. And I can't tell you how many hours I spent in the Boeing facility in Houston testing software. And we said, you know, we really need to test it with the actual hardware. And we convinced them we needed to do this mission essential integration test at the Cape. And we used emulators and actually tested there, and we found more things that weren't right. But we went over and tested things in Russia. And then when we got on orbit, everything fit. Everything worked. When I sent the commands to actuate the computers on the International Space Station, nobody was more surprised than me when everything worked perfectly, you know? But I shouldn't have been, because we spent hours testing it. And it's making the requirements known and the testing that goes into it and working together with our partners to ensure that you have the proper interfaces. So, yeah, the data are out there, and it takes an integrator, it takes leadership in order to bring that all together, and that's what I believe NASA provides. Yes, sir.
My name is Wes. I'm a student for you. Something that the last speakers talked about was preventing starts and stops in funding. How, from a NASA perspective, are you guys preventing those starts and stops in funding and continuing the project?
Well, fortunately, NASA is not partisan. It's not even bipartisan. It is nonpartisan. Both houses, both parties believe that what we are doing is important. Now, does that mean it's not without its challenges? It's really challenging right now when we look at where we ended up, you know, after this latest, you know, what we did in order to have a budget and not end up shutting down the government. You know, we were looking at a president's recommend of $27.2 billion. We're going to end up with less than that as we move forward. So it's going to require some hard decisions on our part. It may move things out a little bit longer. It may mean that some things have to be stopped. But again, as I said, we can't just cut one area to favor another. We have to look at this smartly. The key here is, from an exploration point of view, is that we have this architecture and we know what we need to do at what point in order to move forward. And that's why it's so important to continue to have these international partnerships as well as our commercial partnerships, so that we are doing it in the most cost-effective and efficient manner that we can. And I think I've used up my time. I think it's time for lunch. I want to wish you all the very best. I hope that you've learned something throughout the day. I looked at the panels this afternoon. I kind of wish I could stay and sit in and listen to them. They've done a great job pulling together some awesome panels for you. You're the future. You're the leadership, so pay attention. Work hard, do your best, and don't ever lose that passion. This is awesome stuff that we're doing, all right? Thank you.
Thank you, sir. Thank you for being here today. Thank you for your leadership in NASA, and thank you for NASA's leadership in the world. It's really impressive, and we're grateful to have you. So thank you, sir. So now we will, as we talked about before, break for lunch. We will reconvene here at 1:45. While you're having lunch, please remember to focus on networking, check out some of the exhibits that have been set up, some of the hardware and handouts. And also, I just want to acknowledge our sponsors again before we go to lunch, but this time with the, note that a lot of our sponsors are hiring, so if you are in a position where you're looking for a job, please check out our sponsors' websites, Advanced Space, Voyager Space, Virgin Galactic, Astroscale US, Bryce Tech, Rocket Lab, Blue Origin, and then the Brooke Owens Fellowship Program, Space Intel Report, Zed Factor Fellowship, and SEDS USA. Some of those nonprofits might not be hiring, just to be clear, but they might be, so check out their websites. Appreciate our sponsors. Please enjoy lunch, and we'll get back here at 1:45. Thank you.